Welcome. In this video, we are going to learn about the basics of 3D space. If you guys have ever used Hatch before or any other 2D or 3D game platform like MIT Scratch, MIT App Inventor, or Unity, or any other 3D platform, you would have noticed that these X, Y, Z numbers keep popping up everywhere. You see, like even for my box here, I have X, Y, and Z numbers for position, rotation, and scale. And same goes for the sphere here. Sphere also has some X, Y, Z numbers for position, rotation, and scale. And every other object here and in all other 3D platforms, you will notice that they all have these X, Y, Z values with some numbers for position, rotation, and scale. So our aim for today's session is to learn about what these XYZ values are and why do we need them and how can we use those values to add animations to our objects in this Hatch workspace. So let me run this code that I have here. This is a sample code that I have prepared for you. And you will notice that when I click on the green play button, my box moves up and down and up and down. And it's moving so smoothly. And you will notice that nowhere in my code am I saying my box to move up or down. Rather, I'm changing its XYZ numbers in this code. And using those numbers, I'm just moving my box up and down. So this is going to be the basis of today's session. We are going to understand why we need XYZ values and how to use those XYZ values. All right, so let's get started. So first of all, I want to talk about why do we need these XYZ values. All right, so I just have a whiteboard opened up. Let me go here. Now in the real world, let's take you for example. Okay, so let's say this is you. Okay, this is you and you are facing your friend who is standing in front of you. All right, so now you'll notice that your forward direction and the forward direction for your friend, this is you and this is your friend. Okay, so the forward direction for your friend is different from the forward direction for you. All right, similarly, let's take another example. So I'm just going to, let's say we are all standing on Earth. So this is Earth. Okay, so now let's say there is a person standing on the North Pole here, right? And there is another person standing on the South Pole here. Now the up direction for the person on the North Pole is different from the up direction for the person on the South Pole, right? So why is that? Because for this person, we can see that this person is standing down, standing upside down with respect to this person. But they don't know that, right? This person is in his own field of view and this person has his own views, right? So from both of them, if they are said to move up, one will move in this direction and one will move in this direction. They will be moving in opposite directions, but they will be moving in their own up directions. They will be moving in the up directions with respect to themselves. So what happens is directions are relative to every object. They change from object to object. That is not a reliable way to communicate to our computers how to move objects, right? So what we do is in mathematics, in computer science, in science in general, we define movement in terms of three axes. So we by default define three set of directions. So that is why we call it 3D games or 3D space. It contains three dimensions. Okay, so by default we define three set of directions. We define one direction to be X, we define another direction to be Y, and we define a third direction to be Z. All right, so now these X, Y, Z are basically number lines. You guys would have studied number lines in your basic maths classes in younger days. In grade 1 or 2, you guys must be studying about number lines. So number lines are basically, so if x is a number line and this point is 0 for x, so this is 1, 2, and in this direction it goes positive numbers, right? And in this direction you go negative numbers. So this is the negative x direction and this is the positive x direction. All right. And similarly, this is the positive y direction and this is the negative y direction. And this is the positive z direction and this is the negative z direction. So once we define these set of directions, then if let's say I want to tell my person on the North Pole to move in his up direction, I can just tell him to move in the positive y. And if he knows these x, y, and z direction values, he will know to move up, right? And if I want to make this person on the South Pole move in his own up direction, all I need to tell is for this person to move in the negative y direction. And he will be moving in his own up direction, right? So once we define these x, y, and z set of directions, we can easily communicate to all the different objects that we have in a 3D space to move wherever they want with respect to these x, y, and z values. That is why we use these x, y, z values. So these are called coordinates. All right. So any motion in a 3D space. So let's say I want to move this side. I can break down my motion, or any motion. Let's say I want to move somewhere diagonally this way. So my motion in this 3D space can be broken down into a combination of moving in the x-axis, moving in the y-axis, and moving on the z-axis. So if I, let's say, want to move this way, that means I'm moving in the positive x direction as well as in the positive y direction, right? And let's say somebody is, let me use a different color here. So yeah, let's say somebody is standing here that is basically somewhere far away from x, y, and z. And this person now wants to move like this. So his motion, wherever this person is standing, from that point, this person's motion can be broken down into a combination of moving in the positive or negative x direction, moving in the positive or negative y direction, and moving in the positive or negative z directions. So like even on a piece of paper, let's say you have a piece of paper and you want to scribble something. So if you want to scribble something on a piece of paper, you can only move your hand left, right, or up and down, right? So if you want to scribble something, whatever you scribble, the motion of your hand will be comprised of a combination of left and right direction and up and down direction. And anything you write on a piece of paper can be broken down into whether your hand is moving left or right and up and down. So on a piece of paper, when you draw something on a piece of paper, you are moving in 2 dimensions only. So that is why it's called a 2D space. And in the real world, we can move in 3 set of directions. We can move left or right in x, up or down, that is y, and front and back, that's the z direction. So the combination of these 3 dimensions is why we call the real world a 3D space, and why we call what you see on your screen or what you see on a piece of paper as a 2-dimension space. All right. So now that I have explained to you guys what x, y, and z values are, let's go back to our Hatch workspace and see how these x, y, and z values are implemented for different objects in the Hatch workspace. All right. So I'm going back to my Hatch workspace, and by default right now I'm in the coding window. So let's go to our design space. All right. And as you can see here, I am in the design workspace. Now let's select our box here for the time being. So you will notice that when I select my box, on the properties panel of my box, its position, you see the position property has x, y, and z. So x position of my box is -1. And you will notice that when you select your box, you can see these 3 arrows. that are defining what are the x, y, and z directions. And you will see that they are the same for sphere and for the cylinder and for every other object that you select in this 3D space. The x, y, and z directions are constant. So when I say that the position of this box is -1 in x, my computer knows that in the x direction, its position will be set from 0 to -1. So if you remember, I said that these x, y, z are numbered lines, right? So there is 0, 0, and 0. So the zeros of all of these three numbered lines is where these three axes meet. All right. So this is called the origin. Origin. O-R-I-G-I-N. Origin. So that is where the x, y, and z coordinate axes meet. All right. So this is 0, 0, and 0. And if you move to the right side, your x number value will increase. It will become 1 or 2 or 3. And if you move to the left hand side, the x number value will decrease. So it will become -1, -2, and so on. So when I say someone's position is -1, it means it's -1 units from this 0. Okay. So that is what I mean when I say that the box's position here is -1 in the x unit. So it's from the 0 position. So if I type 0 here, my box will go to the x0 position. All right. And right now you see it says the y position of my box is 0.5. So if you make it 0, you will notice that the box has moved to x0 and y0. And in the z direction, my box is at -3. So if you click here and type 0 as well, so now my box has moved to x, y, and z 0, 0, and 0. And if I, let's say, want to move the box up, I can just increase its y value. And you see, as I'm clicking on this y axis and moving the box up, you will notice that the position number here keeps on increasing. If I want to make the box move down, I am moving it down, and you see the y number is decreasing. So if you want to define the position of an object in a 3D space on a 3D program, all you have to do is move or change its x, y, and z numbers, and your object will move wherever you want it to move. All right. So let me just move it back to -1, 0.5, and -3. So my box has moved back to its original position. And here my sphere has x, y, and z values as well. And my cylinder has some x, y, and z values as well. Now you will notice that this was the position, but there is also rotation and scale. So scale defines the size. Okay. Scale is easier to understand. So I'm going to explain scale first, and we will come back to rotation. So scale defines the size. So I know that x is this left-right direction from where I'm standing, and the y is the up and down direction, and the z is this front and back direction. So when I say the scale of this box is 1 in x direction, it means in the left-right direction, the box's width is of its original size. You can make it 2, and the box's scale has increased in the x direction. If you make it 2 here, the box's height has been increased in the y direction. And if you make it 2 in the z, then its depth has also increased. So whenever you want to modify the size of any object, if you want to modify increase the size uniformly in all directions, then you need to provide equal numbers in x, y, and z. So if you want to make the box, let's say, half of its original size, you just need to give 0.5, 0.5, and 0.5 in each of the x, y, z values. And, well, my box has become half of its original size. Not exactly half, it has become 1/8 because of its volume. But yeah, units lengthwise, it has become half of its original size. So yeah, that was scale. Let me go back to 1, 1, 1. 1, 1, and 1 means an object is of its original size. All right. And then comes rotation. So let me go back to my whiteboard and let me clear some things out from here. So I am, let's just scroll down and draw a new coordinate space. So I have x, y, and z axis. Okay. So this is my x, this is my y, and this is my z. All right. So how is a rotation defined for an object? So let's say I have a box. All right. So when I have a box, if I want to rotate this box somewhere, what I can do is I can rotate this box by a combination of turning in the box around the x-axis and turning the box around the y-axis and turning the box around the z-axis. All right. So let's say I want to rotate the box. So let's go back to our hatch workspace. Now here you will notice that the box's rotation is already 45 degrees in y. Let's set it to 0 for now. All right. So this is my box in the normal state. All right. Now you see, if I change the x rotation, you see the box is turning around only its x-axis. All right. And similarly, if you just change the y rotation, the box is turning only in the y-axis. You can see from here, right? And then if you change the z rotation, the box is rotating about its z-axis. So that is what the x, y, z rotation values are. So now if you want to move an object, rotate an object any way that you want, you just need to rotate it in a combination of x, y, and z rotation values, and you will be able to get a desired rotation. Now, every time we might not know exactly what values for position, rotation, and scale that we want. So that is why you have these three buttons here. You can just select these three buttons and easily manipulate the properties however you want, like visually position, rotate, and orient your object however you want. And then the numbers here will change on their own depending on what you are doing here. All right. So if you select translate, translate means changing the position, then you can move your mouse over the x, y, and z axis and move the object only in the x, y, or z axis. But also, see here you have, if you select this plane here, so you see this highlights x and y axis both. So when you select this and click your mouse and drag, now you can change the x and y values together and keep the z value constant. So look at the properties panel here. All right. Only the x and y values are changing and the z value is not changing. And then similarly, you can change just the y and z position or just the x and z position. And then if you just move your mouse to the center, then you will be able to change all three positions together. And then same goes for rotation. So for rotation, you have these three circles and this big circle to change rotation however you want. And for scale, you have changing the scale in x, y, and z, and then the center point defines scale altogether. All right. So we have learned how to modify the position, rotation, and scale in the design mode. I am just going to set this thing back to -3, 0.5. So sorry, -1, 0.5, and -3, and 0, 0, 0, 1, 1, and 1. And I'm going to say to 45 degrees in the y rotation. All right. So I have moved the box back to its original values. All right. So now that we have learned about the how to manipulate an object's XYZ values in position, rotation, and scale in the design mode, let's understand how can we use these values to animate an object using code. So I'm going to go to the code window here. And yeah, so I already have this code. And you have already seen that when I click on the green play button, what this code does is it makes my box bounce up and down. All right. But let's just code this entire thing by ourselves. So I'm just going to delete this entire thing and I'm going to reload this. All right. So we have learned that when you click on the box here, so we learned that to change an object's position, we can So there are these blocks that says move forward and backward and all of these, but that's relative to the objects, to each object of its own, right? But we also learned today that we can change the object's position, rotation, and scale by changing its x, y, z values in position, rotation, and scale. So when you click on an object's name on the left panel here, you will notice that there are blocks that say like change box x by 1. What this means is, let me bring out an event block. And if I attach this block here, this says, what does this say now? It says when green play button is clicked, change boxes x by 1. This means that when I click on the green play button, the x position of my box will increase by 1. And then it will again increase by 1. Every time I click on this green play button, I am just manipulating the box's position by changing x by 1. So we know that the x-axis was pointing in this direction. That is why my box is moving in this direction. I can manipulate this and say change x by -1, and now every time I click on the green play button, my box is moving in the negative x direction. Yeah. So from now on, motion in 3D space, I'm mostly going to refer it as positive x, positive y, and positive z and negative z. So I can say, let's say change box y by 2. And every time I click on the green play button, you see now my box is moving 2 units in the positive y direction. All right. And I can just say z as well. So now my box is moving in the positive z direction by 2 units every time I click on the green play button. All right. So let's say now I want to make the box move up and down. All right. So we know that to move up and down here, we will need to change the box's y position. And to make the box move up, we will need to modify the box's y position. We'll need to increase the box's y position. And to make the box move down, we will need to modify the y position by decreasing it, right? So once we'll have to increase the box's y position, and then once we'll need to decrease the box's y position. So how can we do that? So for that, what I'm going to do is I'm going to create a variable. So there is a variables category on the top here. Click on that and select create a variable. So you will notice that I have already created a variable called speed, but you will need to click on this variable, create a variable button, and then just give your variable whatever name you want. So I'm calling my variable speed because my variable is going to define with what speed my box is going to move up or down. All right. So once you give your variable a name, you can click on create and your variable will be created. So I have already created the speed variable here. And what you need to do is just bring out the set variable block on the top. Click and drag it out outside and select your variable name here and then give it some value. So right now I know that I want my box to be moving upwards. So I will give the speed a positive number value. So how do I get a number value? I can click on math here and bring out this create a number block, or an easier way would be just press shift and M on your keyboard, and this will generate a number block that you can attach here. So I'm saying set variable speed to 0. Now I want my box to move up. So if I say speed x is 0, I won't be able to move the box by at any value at all. So let's give it some number. Let's say speed is 1. All right. So now what I can do is I can say change box's y position, and we can delete this number block here. And by what value? We can click on our variables option and bring out the speed block and attach it here. So now when I click on the green play button, it's moving by whatever value the speed variable has. So my speed variable has the value 1. If I make it 2 and click on the green play button, now my box moved 2 units up. If I say -1 and click on the green play button, my box is moving down now. All right. So you can use these variables, and now all I can do is I can move my box up and then change the value of speed, and then we can make the box move down by just changing the value of speed in between its motion. All right, so we are going to do that. So let's just set this to 0.1 for now and reload this project. So I want the box to continuously move up. So for that, I will need a loop block. So I'm going to click on this loops and timers and bring out this forever block that I have here. And I'm going to attach this change y by inside my forever and say it here. So I'll change the box's y by the value of the speed. And so right now I know that the box's y position is 0.5. So when I increase the y position of my object, of my box, it will become greater than 0.5. So at some point of time, my box's y position will become, see, it keeps on moving up. Okay. So let me reduce the speed 0.01. And if I click on the green play button, my box is moving up and up. And at some point of time, its y position is becoming 1, becoming 2, 3, 4, 5, and so on. Right? So now what I can do is I can add an if statement, a conditional statement. So I will click on this logic button here and bring out this if do block. And here now I can say if the box's y position has become greater than 2, it has moved above the y position of 2, then I want the speed to become negative. Then change the speed to a negative value. All right. So how do we write that in terms of code? So here I will say if the y position of the box is greater than 2. So go to our logic blocks, and here there is this logical operations block. You can bring this out and attach it here. Now I just have to select this equal to symbol. I can say greater than symbol here. So now I have to say the y position of the box. How do I say the y position of the box? So go to your box, and here you will see that there is a category of blocks called getters, and you have these circular shaped blocks that says boxes position x, rotation x, scale x. So you can select out this position x block and attach it here and change position x to position y. So this will tell your computer whatever is the position, the y position of your box. So if the y position of your box is greater than what? Is greater than 2, then what do we want? We want to set the value of speed to minus 0.01, right? So let's see if this works or not. Let's click on the green play button and see my box started moving down. Now I don't want the box to go below the ground. So once my box is on the ground, I want the box to start moving up again. So I know that to stand on the ground, my box needs to have a y position of 0.5. So all I have to say here is, you see, I can click on this settings button on the if statement and I can add another else if block. So I can add another condition. We added one condition of box's y position to be greater than 2. If the y position of the box has become greater than 2, if the box has moved above the y position of 2, then make it move down by changing the variable speed to minus 0.01. Now what I can do is simply say if the box's y position has become less than 0.5. So when the box is moving down, its y position is decreasing. So when the y position of my box has become less than 0.5, so I can just right click on this blue block and duplicate this and attach it here and say box position y less than 0.5. And then what do we want? We want then the box to move up. So its speed should become positive again, right? So I can just duplicate this and say set variable speed to 0.01. And now if I run this code, see, my box is moving up and moving down. All right. So I hope you guys understood what XYZ values are. How can we manipulate the XYZ values of an object and use those values to animate the position or rotation or scale of an object, right? So right now I have only changed the position, but similarly you guys can just change the box X scale, box X rotation, and change X, Y, or Z scale and rotation, and make an object do whatever you want in this 3D space. All right. So I am ending this video here, and I'm going to add another tutorial. Using in that tutorial, we are going to use the X, Y, and Z values of an object to create our own character, our own 3D character, and code an animation for it. So let me show you what the project is going to be. I'm going to this my projects option. All right. So I have this project here called create your character. If I click on edit project, so you will see here that all I'm doing is I'm just changing I have this 3D character. I have created this 3D character using only boxes and spheres. That is all. Using only boxes and spheres, this 3D character has been created. And in the code, you will notice that all I'm doing is I'm changing the Y rotation, X rotation, and the Y position. And let me run the code and show you what this does. This makes my character jump up and down with this hand and leg motion. It looks realistic enough, right? So we can create whatever we want in this workspace and use the right blocks to make the objects do whatever we want. All right. So this is going to be our next tutorial video. All right. See you guys in the next one. Bye bye.